Hey, welcome. We're going to look at using law of sines to solve oblique triangles. Oblique triangles do not contain a 90-degree angle, and so therefore they don't fall under the right triangle rules like Pythagorean theorem. We can't use them on oblique triangles. So if you need to pull up the law of sines in your identities sheet on Google Drive, feel free. I was able to sneak them in here just to help out a little bit for your convenience. The first triangle we'll look at is angle C. Remember, angles are capital letters. Angle C is 102 degrees. Angle B is 29 degrees. And side B is 28 feet. Apostrophes are used for feet. Lowercase letters are opposite of their capital letter partner. When you go around this triangle, you have an angle, and a side given. So that's why I put AAS triangle here. If you know two angles of a triangle, you can always get the third angle by subtracting the two that you know from 180 degrees. Since we are given two angles, we can get angle A by taking 180 degrees and subtracting the two angles that we know. That gives us 49 degrees. Now, I didn't write these answers in the diagrams just to avoid clutter. So that's the first thing. If you ever see you've got two angles, subtract them from 180, that's automatically the third. That's always money in the bank. Now, because none of these angles are 90 degrees, we can use what's called law of sines, and it's setting up a proportion of a side length to its opposing sine of that angle. So we'll take, let's suppose we want to get side A. Side A. We need to set up a fraction of A over sine of capital A, or angle A. The other fraction that you compare it to, you need to know both side and angle of the same letter. Side B, angle B. In the law of sines, you will only use two of the three at a time. Multiply both sides by sine 49. Make sure your calculator is in degree mode. If it is, type in your numerator. Make sure that you get all the numerator together before you divide by sine 29. Be very careful. You will need to close off parentheses behind the 49 before you hit divide. This is the approximate length of side A. Now that we know side B, side A, angle A, the only thing left is side C. So lowercase c, which is the side of C, over the sine of its opposing angle, is equal to, now once you've got a complete fraction, you can stick with it. Notice I use the same comparison ratio here. Multiply both sides by sine 102, and again, degree mode. There's your approximate length of side C. I did put a note here at the bottom. It's very tempting if you know two sides to use Pythagorean theorem to find a third. That only works in right triangles. A pole tilts towards the sun at an 8-degree angle from the vertical, and it casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? Normally in these problems, you always have the best case scenario with a pole or a flagpole, whatever it is. It's always very vertical from the ground, and you can always have a 90-degree angle. This particular pole has a lean to it, so let's pretend the sun is over here. The pole leans 8 degrees towards the sun, but it's still going to cast a shadow. The shadow is 22 feet long. From A, the angle of elevation to the top of the pole is 43 degrees. So angle B is actually 98 degrees because perpendicular plus an 8 degree tilt. Well, we know B and A, so subtract those from C, or excuse me, subtract from 180 to get C. 180 degrees minus 98, and that's from the pole being tilted 8 degrees from the vertical. And then angle A, the elevation's 43 degrees. Angle C at the top is 39 degrees. Now we know all the angles. We don't know the sides. We were asked to find how tall the pole is, or the height of the pole. Well, that's opposite of angle A. So we're going to use this fraction, side A, which is the pole, over sine of angle A. Since we happen to know both side C and angle C, we'll use it as the comparative ratio. We're going to compare it. You will always know 3 of the 4 parts. Multiply both sides by sine 43, and the height of the pole is just shy of 24 feet. The area of a triangle is 1/2 the product of the lengths of 2 sides times the sine of their included angle. This is for a sine angle side situation. Side, angle, side. The angle in between 2 sides. And from the paragraph at the top, the description, we're going to take 1/2 of the product of the 2 lengths, so 1/2 of 52 times 90, times the sine of the angle in between, which is 102 degrees. Put this in your calculator. It might be easier actually to type this in as 0.5, and then you can just type it all in at one time. Area is in square measurements. These are in feet, so the area is 2,289 square feet. Find the area of the triangle. This is a second example. This one, we have angle, side, and angle. You always look at them consecutively. Well, angle, side, angle doesn't fit the SAS, or side angle side, description. That's okay. We can get angle A, 180 minus 118 minus 29. That's 33 degrees. So angle A is 33 degrees. There's a couple of ways to approach it. Remember, we're looking for side, another side, and the angle between. You can either solve for C, and then you can use C, 118, and 52, because that's side angle side, or you can solve for B, and then you can use what you get for B along with 29 degrees and 52. It really doesn't matter. That's why I put this note over here. Pick one. As long as you get a side, an angle, and a side, you can apply this formula. I just randomly chose side C. C over sine 29 degrees is equal to 52 over sine of 33 degrees. One fraction you have to know both parts, the other you need to know one of the two. Multiplying both sides by sine 29. Careful entering in your calculator, you get 46.3 feet for side C. Now we have side angle side. Let's apply the area formula. 1/2 of the 2 lengths, 46.3 times 52 times the sine of the angle between. That's sine 118. That gets us ballpark 1,063 square feet. I hope this video helps. If you have questions, please reach out by email, phone, or if we're in a traditional setting, ask in class. I'll do my best to help you out. Thank you.